Hello. Now let us try to understand the construction of a cam profile with the help of this problem. Now let's see what is given in the problem. It is said that draw the profile of a cam operating a knife edge follower having a stroke of 30 mm. The cam raises the follower, that means the outstroke, with SHM, simple harmonic motion, for 150 degree of cam rotation, followed by a dwell. So after rise there is a dwell, and dwell is of 60 degrees. The follower returns with simple harmonic motion in 90 degree of cam rotation, that means 150, then 60 degree of dwell, and then for next 90 degree rotation of the cam, the follower returns with simple harmonic motion, and then again it is followed by a dwell of the remaining period of the cycle. So the cycle is of 360 degrees. Now the cam rotates at uniform velocity. The velocity, that means the speed in RPM, is given to us, and has a least radius. So least radius, that means the base circle diameter, is provided. Again, another thing is asked, what will be the maximum velocity and acceleration during the outstroke? So going through the given problem, first we'll write whatever the given data. So the stroke is given 30 millimeters. The type of the follower is knife edge follower. As well, when nothing is mentioned, we will also consider that to be as a radial follower. Now radial follower means what? That the line of the stroke and the center of rotation of the cam, they are lying on the same straight line. Then let us try to understand the cam motion. The rise is for 150 degree of cam rotation through simple harmonic motion. Then there is a dwell. Dwell means, that means the follower after rising for 30 millimeters of stroke, it is staying there for 60 degree rotation of the cam. Then when again next 90 degree the cam rotates, it is returning back, and this return motion is also simple harmonic motion. And again after 90 degree, then the remaining cycle, that will come out to be as 60 degree. So it is dwelling. There is a dwell. As well, the base circle radius is given to us, which is of 35 millimeter. The speed of the cam is provided, which is 120 RPM. When nothing is mentioned as such as the sense of rotation, we will consider the sense of rotation of the cam to be as clockwise. So first thing first, then if we see the last part, maximum acceleration and the velocity of the follower, what will be the maximum velocity and acceleration of the follower? It will be actually during the outstroke. That is what we need to determine. So for that, I'll have to first find out the angular velocity. So it will be 2 pi n by 60. So that will be 2 pi 120 by 60. So when we calculate, we get this value as 12.566 radians per second. Now for SHM, if you see, the maximum velocity, you can say Vmax of the follower, is given by S by 2 pi into omega of the cam upon theta of the outstroke. We are finding it for the rise or the outstroke. So this is theta given to us. Theta for this will be rise, it is 150 degrees. So we can find out this value. S is 30 stroke, so it is 30 by 2 into pi. Omega we have just now found out, by, now this will come out to be as, we have to take this in radians, so pi by 180 into 150. So then we will get the maximum velocity. When you calculate this value, we get the maximum velocity as 226.19 millimeters per second. This is one value. And maximum acceleration, if you see, this is given as s by 2 pi omega, again for outstroke, square. So when you put these values and calculate, somewhere we will get this value as 3410 point something millimeters per second square. So these two values are required to be determined. So these will be the two values. Now after going through this, first thing will be to draw the follower displacement diagram. So we'll go for the follower displacement diagram first. Now, so for that we will be drawing the follower displacement diagram, that will be the cam rotation against the stroke. So the horizontal line will represent the cam rotation. So I mention this as theta in this direction. So we take this as the reference point 0, and perpendicular to it will be the, so I measure, so we have to take this as the y-axis, and this will be the stroke. So this is the stroke or the lift, which is given to us as 30 millimeters. So we measure 30 millimeter. Now for SHM, we'll take help of a circle to draw the or get the displacement. So we have taken this as the stroke, which is given to as 30 millimeters. So we take the stroke as 30 millimeters. So now we'll have to take help of a circle. So we find out the midpoint for the stroke, and the stroke to be the diameter, we draw a semicircle, and then we divide this semicircle into 6 parts. So it is easier to divide a circle into semicircle into 6 parts. So that means we are dividing the lift of the follower into 6 parts. So I get this, then the radius in compass. So we get these 2 points, and then this as center, these 2 points. So this is 0, 1, 2, 3, 4, 5 and 6. So this is how the follower is getting lifted. So maybe here now I can, now similarly, as we are lifting the follower in 6 steps, so we'll take 6 equal steps in the for the cam rotation. Now this distance we can decide, so I can take any length in my compass, somewhere around maybe 10 millimeters or so maybe, but we have to see that whatever distance we are taking, that should be same. So this is in 6 parts, so we take 6 parts, so 1 2 3 4 5 and 6. So 1 2 3 4 5 and 6. So this is cam rotation theta in the x-axis. So now matching with the stroke, so we draw these vertical lines through 1 2 3 4 5 and 6. And to get the displacement of the follower or the lift of the follower for each step, so we match our scale with the horizontal. Now from 1, so this is 1, then from 2 we mark 2, 3, 4, 5 and 6. So these are the points we get the each lift of the follower. So when we join all these points with a smooth curve, we get the displacement diagram of the follower as SHM. Now what we have done this for, so this is the rise, which is of 150 degrees. So as if we have divided 150 degrees into 6 parts. Now then again I can mark any random distance to express dwell. So from 6 to 7 is the dwell period, so we can demark them. So this is the rise, and from here to here we are showing this as dwell. So this dwell is of 60 degrees. Then so from 6, this is the 7th point, so I mark this point as 7. Then 7 onwards the follower is going to drop. So again, if the return is also mentioned as SHM, so for the same, again I'll have to go for the same circle, so I can take help of the same circle to describe the fall or the return. So again in 6 steps, so what is happening, the return of 90 degrees also we are again taking in 6 steps. So again, whatever distance, we'll just make sure that whatever, it can be any distance. Only thing is we have taken this into 6 parts, so it will be dropping down as well in 6 parts. So these will be 6 equal parts. So 2, 3, 4, 5 and 6. So that means after 7 it is 8, 9, 10, 11, 12, 13, and again remaining so is dwell. So I'll show the remaining. It can be again any random. So this will be 14th or the 0th again. So that will be, so similarly we will again mark or draw these vertical lines to get the return displacements of the follower. So that means So 7. So it is the follower has reached to the top. Now it is coming back. So that means 7 it is. So this is 8. This is 9. This is 10, 11, 12, and finally 13. So these are the corresponding points of lift. So we again draw a smooth curve passing through all these points. So we get this as the return, and finally this is the dwell. So from 7 to 13 is return, and from 13 to 14 is dwell. So this is return and this is again dwell. So this is return of 90 degrees and this is dwell of remaining 60 degrees. So that is how we finish the displacement diagram, and now we will move for to get the cam profile. So for the cam profile now, first we'll locate a center. Let this be kind of an axis line. I mark one point. I name this point as O as the center of rotation of cam. The base circle radius is given to me as 35 mm. So I mark 35 mm and I first draw the base circle. So this is the base circle or the least radius first we draw, and let us take the stroke to be perpendicular to the perpendicular direction. So let this be, so this is the line of the stroke of the follower. Now the follower mentioned to us here is a knife edge follower. So we just simply draw the first position of the follower, say as this as the follower. So this is the follower, maybe in between the guides. This is the line of the stroke. Now it is mentioned, or we have considered that it's a radial follower, so the line of action, line of stroke is passing through the center of rotation, and we will be considering this to be as the radial. So this line and center of rotation is coinciding, and we have considered the motion of the follower to be cam to be clockwise. So it is turning this way. So when we are drawing the profile, we will be considering the follower to be turning. So if this is rotating clockwise, that means follower with relative to this is turning counterclockwise. So we will be locating all the trace points in counterclockwise sense. Now you will see that in case of a knife edge follower, the trace point or the pitch point will be the point of contact. Now, so when this is turning for the first 150 degrees of rotation, the follower is moving outward. So first now we will mark 150 degrees. So we mark 150 degrees. So from rotation here to here, the follower is rising. So this will be the line of stroke, and this is 150 degrees. Now we have divided this, or we have, for the rise we have divided the rise into 6 steps. So we'll divide this 150 degrees into 6 steps. So each step will be then of 25 degrees. So from here, so 1, 2, 3, 4, 5 and 6. So we'll be drawing these line of the strokes for the so these are the line of the strokes. So this is the 0th position. So this is 1, 2, 3, 4, 5 and 6. So now we take help of the displacement diagram. So when it has turned by first step, the displacement is, so we take the displacement value from the displacement diagram and we mark the first displacement. So this is the first point. Then displacement for the second step is, so from 2 we take this value. From the base circle I get this point as this. For 3, so we take this from the displacement diagram as 3. So for the third step, from the base circle, follower will be lifted here. Then for the fourth step, from the base circle, this is 4. For the fifth step, from the base circle, this is 5. And for the sixth, we get this as 6. So we get all these points as this trace point, which will give me the cam profile. So now when we join all these points with the help of so this is 1, 2, 3, 4, 5 and 6. So when we join all these points with the help of a smooth curve, this will be the cam profile for the rise. So we can confirm this. So when we are joining this with the smooth curve, so we get this as the profile for rise. Now the follower is going to dwell for 60 degrees. So from here we will measure 60 degrees. So 60 degrees. So from 6th to 7th, so this will be the 7th step. 6 to 7 is a dwell. So when this is dwell, the follower is going to, displacement is going to be same. So from here when I mark this, so this is the 7th point, and distance of the follower from the center of rotation is not going to change. So this is what is dwell. So directly the center of rotation as center 6 to 7, we can simply draw the circular arc. So I confirm it. So here this is the rise profile, this is the dwell profile. Now 7 onwards it is return. So we'll now again divide this 90 degree from here. 90 degree of cam rotation is, so from here, to this, the cam is going to so this is the 13th line of stroke which we have drawn. So from here to here, so now we will divide this 90 degree into 6 steps again. So when we divide this 90 degree into 6 steps, each will be of 15 degrees. So we will mark 15 degrees, 10, 15, 30, 45, 60, 75, 80. Right? So these are the line of strokes for return. So this is then 8, 9, 10, 11, 12 and 13th. Then 14th and 0 will be this. So now we make the follower return. So for return again, the displacement will be this. So I measure the displacement 8 from the displacement diagram. So again from the base circle, so this is 8. Then we take 9. So from 9, then 10, eleven, and then 12, and finally 13. So these are the trace points. So this is 8, 9, 10, 11 and 12. This is 13th. So again we'll join all these points with a smooth curve. And finally it will meet the base circle. So that is how we get. So now we can confirm. So, and finally the remaining dwell is of 60 degrees. So again here this is the return and this is dwell. So this is how then we get the cam profile. We have already found out the conditions for Vmax and acceleration maximum during the outward stroke, which is, so that is how finally we get the cam profile.